Start the recording. Okay, ladies and gentlemen. So with that added population size associated with the population, it's recommended by the virtues of being able to change the population size without changing the model. Time is short. Time is fleeting. Winchell and Kurt will be presenting after lunch, and I want to ensure that they have the time necessary to walk you through some exciting examples. So we're going to be working to wrap this up with an economy of mechanism. So we want to have these two state charts joined so that one's smoking status worsens one's chance of heart disease. How could I accomplish that? How could I accomplish it so that my chance per unit time in developing heart disease depends on which state I'm in? What can we do? What can we do? Okay, here a function. It's actually something we could do with a function, but there's a way to do it elegantly. We've actually explored. Let me rephrase it. How did we have the color of a person? How did we have it? This little person representation know what color to show based on their smoking status. We used a what? Begins with a V, ends with an E. It's a variable. How could we have heart disease? What's your incidence rate for heart disease or hazard rate of developing heart disease depend on your current smoking status? What could we use to communicate the current smoking status and the risks, the hazard rate of heart disease for that smoking status to this state chart? We could use a what? Okay, there's a rule, yeah. It's going to be specified based on this context. It's going to be different. That's right. But what particular way did we use to communicate from this state chart what color should be? We used a
in state.
Okay. Oh, okay. But for smoking status, we used color. This should have been called fill color, or should have been called smoking color, or something like that. We used a variable, right? Could we do something like that to communicate from this the current, based on the state we're in, the hazard rate that applies here? Yeah, we could communicate a smoking state specific hazard rate from this to this using begins with a V, ends with an E, variable. Yeah. You folks are really good. I stand in this very room. I teach a course during the semester, and sometimes I have to play hangman. And the guy comes pretty close to the gallows. Yeah.
What is the main difference between the variable and parameter?
Good question. I get that many of my boot camps, and there's a profound difference, but it's not obvious to people using any logic at first glance. There's a conceptual difference, and there's practical differences. Let me count them. So one difference is that at a conceptual level, parameters typically encode quantities that will remain constant through the simulation. Not always, but typically they vary very little, if at all, and in most cases, 98, 99% of the cases, I'll use a parameter for something that does not change. For example, I have a parameter to indicate what my home is, and I don't switch homes. Or I have a parameter that indicates my ethnicity. I have a parameter that indicates my birth weight, weight at birth. Those are parameters. Those aren't changing. Those are assumptions about me that are fixed, and I would encode that with a parameter. Okay, with a variable. Variables denote, as their name depicts, with one exception that I find highly objectionable in terms of verbiage. Variables denote things that vary. variable. So we use them often for things that change, like someone's color, or the hazard rate of heart disease, given their smoking stat, their current smoking stats. That will vary. You understand that? So parameters encode fixed assumptions, and variables are in general are meant to change. There's an asterisk there, and I can comment on it if there's interest. But first I want to emphasize the other salient difference so we don't lose track of it. Because there's one other absolutely key difference. The job of a parameter in life is to characterize an assumption, number one, and to communicate that assumption to the thing containing that parameter from the point of creation of that thing. So, if we have a parameter in a person, the value to use for that parameter is communicated to that person from the population that they're in, or from the point where they are added to the model as an immigrant or via a birth. Okay? It specifies what assumption they should have, but it also serves to communicate to it from that point. And as you know, if we had a parameter here, for example, maybe we have a parameter that's called called sex here, right? If we had a sex parameter here, when we specify the population, we need to specify some assumption about the sex of a given agent. Remember yesterday we drew it from a distribution? So here the parameters is characterizing the assumption to use for a given person's sex, but it's also communicating that from that point of creation to this place. A variable does not do that. A variable you don't specify at the point of creation. It is given some initial value, which we actually specify associated with it. I'm going to delete sex because we won't be depending on that in the abbreviated form of this. Although I'm sure Kurt and Winchell could, particularly Kurt because he worked with this example, some could elaborate on that. But color is specified in initial value, but that's specified here. It's not specified with what creates this agent. So for a person, the population or the place where they're born or added as an immigrant that specifies the assumption to use for a parameter. For Maine, the thing that creates Maine is the experiment. So the experiment specifies the value to use for parameters here. Whereas for variables, there's no option to do that. You don't have a way of communicating the assumption to use for that variable directly. Now, there's asterisks associated with these things. There's added complexity. It turns out that the two of them are initialized at different times. And I think variables are initialized before parameters. So you don't even want to try to assign a variable from a parameter value because it's not yet available at the time you assign it. And sometimes, and again, one of the most objectionable things, it adds insult to injury. I'm so embarrassed to say it that I feel ashamed, but I must warn you against it. Ladies and gentlemen, number one, there are things called, this is horrible, constant variables. The mind revolts against the terminology. It sounds like oxymoronic. I mean, so you could declare color a constant variable. If you go to advanced, you could say it's a constant. And there are times we will engage in this behavior. And to indicate that, there's actually a visual indication. Don't do this at home, but I will check it, and you'll notice it now is associated with two little bars to indicate that it's constant. At least there's a visual representation that it's a constant. Now, there's a further distinction here, which again uses the most objectionable of terminology. We can declare something so-called static. And what's static, it's horrible. It's horrible. I'm surprised I'm not blushing fiercely. But static actually doesn't mean it's constant. It doesn't mean it's unchanging. What it means is there's only one of it. For all persons, there's only one of them. And it's terrible terminology. It's a case of computer science arrogance in terms of terminological arrogance. Terminological arrogance. But static means there's only one of it shared for all the persons. So just be aware that these things in advance, constant, you can use a constant variable in some cases where you don't want to need to communicate the assumption about it. And there's only one of them for all persons. It's just a constant associated with personhood that you don't want to change for different people. Then you will not infrequently declare it static constant. It's shared for all people, it's a feature of personhood, and it is constant. And it will show up in this kind of crosshatched fashion. And then you can hide this. And you can not show it so that you're not embarrassed by the terminological arrogance of my kind. Like that, okay? So variables, by and large, though, denote quantities that change over time, with the exception being we will not infrequently use so-called static constant things to indicate things that are fixed and common to all people, and they're just sort of characteristics of personhood that we don't need to change from person to person, therefore they don't need to be a parameter. I'm sorry to have to add those asterisks, but I thought I'd add those for those who want to go a bit further. Is that okay? Thank you very much for that question. And I should be blushing. Okay, so I'm going to save this recording.